I'm honored to introduce our next speaker, Smruti Patel. She is the head of engineering at Stripe, where she leads the Leap and data platform organizations. And her talk is Debugging Engineering Velocity. Hello, Smruti. The stage is yours. We're happy to have you.
Thank you. Hello, everyone. We've had a couple of exciting days at this year's Craft Conference. Thank you for coming to this talk. I'm Smruti Patel, and my topic for today is one that's very close to my heart: understanding and assessing engineering velocity. So you're leading a diverse team of smart, talented engineers with complementary skill set. You've got your OKRs, your agile practices, your sprints and story points, your monthly, quarterly business review meetings, and everyone is shipping code consistently. And yet, in your one-on-ones, you're hearing discontent from your engineers about not understanding how their work relates to the business. Stakeholders are thinking that simple features are taking too long. The team is unsure of why users aren't using what you built. Maybe leadership looks dissatisfied with the team's progress. And worst of all, engineers are giving up entirely on your team. As an engineer, a manager, and now an organizational leader, I've experienced each of these instances. Whether it was releasing enterprise software every 2 years or deploying code multiple times a day, be it products, features, teams, or organizational dynamics, I have at some point or the other seen a flavor of debugging this problem. So what have I learned? What makes each of us tick? I strongly believe that engineers don't lack motivation. They're here to do their best work. So the theory of intrinsic motivation at the individual level talks about three things: competence. This is the ability to apply knowledge and skills to gain mastery over tasks that are important to us. Second, autonomy. This is the choice and the independence to pursue interesting work. And finally, purpose or relatedness. This is, why does something matter? Now let's assume that you've solved the hiring problem. You've built an inclusive team of highly skilled engineers with the right domain expertise. We'll also assume that your management and your leadership practices are leaning toward a healthy culture. This is a culture which provides the right blend of growth mindset, radical candor where you can give a lot of feedback, and then psychological safety for individuals to thrive. So competence and autonomy are more or less solved. But how do we as leaders then address purpose? And how does engineering velocity fit into solving for this, our North Star, the why? And this is where Thinking in Systems by Donella Meadows completely blew my mind. It talks about how for any system, you want to identify the set of elements, their interconnectedness, and the function or the purpose that the system aims to serve. Now let's take our engineering velocity problem. To debug this, a naive view is to say, hey, let's just ship faster. Increase your rate of shipping, burn the midnight oil. But in the process, you burn out your team. So then speed becomes only one of those components of the system. So if we were to truly debug all the aspects around engineering velocity, it becomes important for us to then understand what are the associated set of elements and their complex interconnections. So I define engineering velocity in terms of shipping software. With precision, this talks about what are you trying to ship and why. Speed, this is how frequently are you able to ship. Quality, this is what is the failure rate or quality of the software that you're shipping. And lastly, impact. How well does it truly achieve the business goals and add value? So to me, these four collectively represent engineering velocity: precision, speed, quality, and impact. For any software company, our engineering talent, their productivity, their efficiency, and the value they add is the highest leverage. So then solving for engineering velocity becomes crucial to leading those high-performing teams. Now, all this sounds great in theory, but how do you know where to begin? Now, the first step to debugging is to analyze if you even have a potential engineering velocity problem on your hands. Your team is working very hard and it is shipping something at a regular cadence. However, you're still seeing certain markers, maybe at the individual level, at the team, or at the broader organizational level. And here are some questions you could ask. Is your IC feeling discontented or maybe not disengaged in your one-on-ones? Is your team unsure of what its impact is? Or maybe at the business, the broader organization is questioning, like, why does this team even exist? And so are you seeing some of this then manifest through regretted attrition, lower trust in the team's ability to then meaningfully move the needle, perhaps shrunken headcount or budget allocation, or maybe lower buy-in into the promotion nominations of your senior engineers? Now, if you think you've answered yes to one or more of these, then it is time to debug the function, the purpose, and the health of your system. So once you've analyzed that you do indeed have a problem, the next step is to identify where it is. To do this, first identify the phase of your software cycle. Whether it's sprint, whether it's agile, whether it's waterfall, you typically, for anything you're shipping, you go through these three phases of planning, execution, and delivery. And at each of these phases, there are different systems at play. And so different higher order objectives that we want to aspire for. And consequently, different challenges to then overcome. This is the first phase of software development, planning. Here, we want to focus on driving precision through the what to build and why. Two things that we want to focus on here are alignment and prioritization. Let's jump into those. So alignment. This is where we want to seek alignment on what the team is trying to deliver and then what success looks like. This actually helps build that organizational trust and credibility with your stakeholders, with your users, with your leadership. And it involves asking questions like, why should the team exist? Is this problem even worth solving for? And perhaps, what do you not want to solve? Seeking this early buy-in into what the teams own and doesn't, it also helps situations where sometimes context gets lost through those multiple layers of management hierarchy. And to do this, one thing that's super useful is to identify that North Star metric and then to set an aspirational target. So one of my team's charter is to optimize our cloud infrastructure costs. So what we decided to do was we defined a metric called cloud efficiency, and we started measuring it as cloud infrastructure spend as a function of the business. Now, one thing to note here is my team only had partial agency and control over this top line company level metric that the business truly deemed important. So then it was very important for us to be aware of what else was going on in the company, the broader company-wide priorities and constraints, and to then contextualize that with the extent of agency that we had into driving those targets. So we set those expectations up front, saying, here's our metric, here's where we want to be by the end of the year. And then we sought that broader commitment and ownership, which then set up my team for future success. Now, the next aspect of planning is to drive that precision through prioritization. This is about asking, are you building the right thing and for whom? Some teams, like infrastructure teams, have a very wide scope. And such teams constantly hear concerns that the users are unsatisfied. And this can be very demotivating to our engineers, because engineers basically just want to build awesome products for the users. So the principle that I adopt is to say, hey, it is better to have 10 delighted users than to have 1,000 partially satisfied users. And this applies whether your users are internal, which can happen if you're sort of managing your infrastructure within your company, or it could be your external users if you're shipping those products. So to then better assess which users to focus on, we sample different cohorts. And then you pick a certain cohort of users by conducting detailed interviews with them and understanding their needs. We also checked our assumptions and sought alignment with senior leadership to say, hey, Out of all these cohorts, we're going to focus on this one, and here's why. And this helped us figure out how to manage those user asks across various cohorts, and also then understand who thought or who viewed us as being stuck. But we consistently had to consciously make some hard decisions. Now, this lack of dilution of our effort and consequently feature behavior had a very unexpected result. It enabled us to then make those focused set of users extremely awesome at what they did with the tools we shipped. And we didn't peanut butter our effort across all the users too. And this consequently led to higher adoption and happy, satisfied users. So the thing to remember here is there will always be trade-offs. The key is to be intentional about what you're trying to optimize for and why, and then communicate that as early and as often as you possibly can. Now, the counterbalance to keep ruthless prioritization in check is also to be flexible and then adaptable, because otherwise you can lose sight of what's important. There are times when you may not be in full control of your priorities, or you may be over-indexed on the wrong metrics or feeling trash because the metrics keep changing. And this can sometimes then cause engineers to lose faith in the system, demotivating them and making them take the priorities themselves less seriously. However, such change is a reality in a fast-growing company. So then it becomes important for us as leaders to train our engineers to adapt and then to expect that goals will change. One of my teams owns the top-line company-level metric for end-to-end API latency. Now, to reduce noise, we decided to track the tail latency of the most popular API requests by volume. And through targeted improvements, we were successful in bringing the tail down by about 35%. However, we learned that a certain cohort of users who used a different API pattern were excluded from this metric, but were also having a bad experience. So then we modified our metric to include that, which highlighted a new class of problems. And when we made targeted improvements to those, we were successful in shipping a much richer and a broader user experience. So the thing to note here is when we think about our metrics, it's important to understand that metrics can only be an imperfect tool to achieve that tactical or the strategic prioritization. So it becomes important for us to then evaluate if the set of metrics is accurate and if it's truly measuring what we need it to measure. And from there, develop those right feedback loops such that we can iterate and then validate those metrics. Now, the next stage, the first stage was planning, the next stage is execution. Once you've defined the why and the what, it's time to optimize the how. At the execution stage, you want to drive focus, speed, and quality. So this is where I love Dr. Nicole Forsgren's book, Accelerate, which highlights 4 metrics to help high-performing and productive teams to track that how. Lead time. This is the time that is taken from code that's committed to running in production. This helps drive focus. Next is change rate. This is the frequency of deployments to production, which helps track speed. Failure rate. This is the frequency of deployment failures which need rollback or fixes. And this is typically about the number of bugs that you're probably seeing. And then mean time to recover. This is the average time to recover from a failure. Now, with these metrics as the beacon, let's debug each of these. So to drive focus, this is where you want to ask, are you building or doing too much? Or are you doing too little? Every few sprints at the time of planning, you want to evaluate if the team is keeping too many projects active at the same time. Does the team have a tendency to ship multiple different projects or features around the same time? I distinctly remember December 23rd of last year, where one of my infrastructure teams wrapped up 3 big features for some of the various systems that we owned. Now, I was glad on one hand that we'd completed all our goals for the half and everything was awesome and ready for the holidays. But it also made me question if we had been the most efficient in terms of the ongoing context switch that we likely had to do to ship all those three at roughly the same time. So you want to drive focus by reducing your work in progress. This is easier said than done, and it creeps up on me every so often, even though I'm aware of the problem's existence. And so some of the tricks that I use are including explicit goals for every sprint in terms of what we want to deliver. And then using those colors that you see to represent logical units of work. And sometimes if I see an unusually colorful sprint, like if I have 4 to 5 colors, I'll say, let's drop a few colors aggressively using the urgent versus important framework to see what needs to sort of land when. This is where, as a team, we want to measure and discuss lead time, which we can then also expand to include the time taken from planning and scoping a feature to then shipping it to our focused set of users. The next is need for speed and identifying what can get in the way. This is the guts of all our development. And 3 things you can do here to avoid slowing down over the long run are iterate, de-risk, and unblock. What do we mean by this? So iterate is where we want to build it first and then make it better. Some engineering velocity problems, they simply manifest because some projects are naturally slow running projects and they take a long time. This is especially true for infrastructure work. Like for example, if you're building a database abstraction interface. And for such problems, it then becomes important to develop that product mindset to building infrastructure such that you can demonstrate value early. You also want to engage with users and then go deep before you go broad by picking 1 to 3 specific use cases. And you want to do those extremely well, make them extremely niche, and then you iterate. Next is de-risk. This is where, if you're dealing with inherently complex problems which run over multiple years, this could look like migrating from a monolith to a service-oriented architecture. Now, managing such projects requires, again, adding that incremental value and then uncovering unknown unknowns at each stage. So one thing I like to do is think about it as stepping stones and not milestones. And then the key is at every such instance, you obtain just enough data to be able to reevaluate what the next steps should be. Now, this helps reduce future risks while having meaningful impact. This could look like building a prototype of a service which can work extremely well on that one server with the potential to scale to lots more in future iterations. Now, next is unblock. Software engineering, as we're all aware, it requires dealing with technical systems, and a good dose of interaction between humans. It needs those healthy channels for effective communication and collaboration. But there are often times where you can be blocked by how your team interacts with each other, or due to unplanned asks coming from other teams or organizations around you. This is where we want to empower our teams to deal with such situations. And here are some of the things I've found very useful. Sorry. Establish team norms and roles. So you've seen that less conflict between certain engineers or certain team players, and it's clear as to who's doing what. This is where Lara Hogan's RASI, that is who's responsible, accountable, consulted, and informed, has worked very well for me. Quite recently, we did this Venn diagram of responsibilities between me, my tech lead, our finance and strategy partner, and our technical program manager, because we drove this cross-company engineering program, and that exercise helped us set better expectations and avoid stepping on each other's toes. The next is decision-making frameworks. Each of us makes decisions on any given day, some big, some small, some reversible, some trapdoor. And there are times we even need to decide what to decide. So it becomes important to establish clear decision-making frameworks, which can help highlight what decision needs to be made, why, by when, and by whom. And then depending on the situation at hand, one might also share a list of possible alternatives and solutions along with those trade-offs, which you want to then make intentionally. Now, when we make decisions and we work in teams, we also need to have a process where sometimes a team might need to make an exception to fit in a new, unplanned, but very critical swim lane as requested by another team. This is where we want to establish those routes to have those conversations directly and upfront to avoid those late surprises. I love our Go Unblock process at Stripe, which involves and encourages the teams to first attempt how to solve locally and then co-author a template requesting an escalation with our org leaders. Lastly, if inter-team collaboration is slowing you down and negatively impacting your individual or your team autonomy, org design or reorgs are also a tool at your disposal. So this is a very heavy hammer. So please, and it can impact a lot of individuals. So please use it sparingly. Next, to unblock is systems. Now, engineering velocity can also be adversely impacted due to the health and state of our technical systems. There are times when we can be blocked by our own team systems, or we could be dependent on other teams' deliverables, or even due to lack of systemic tools and support. So to avoid this, for existing systems, manage your technical debt. Check if your page load is unsustainable. Are your support tickets piling up? Is your service implicated frequently in incidents? And so to manage technical debt, or the KTLO, keep the lights on kind of work, I've used run rotation or padding in sprint deliverables, depending on the shape or the extent of the work. If I see that debt creeping up, assess that cost-benefit analysis of solving it now and sacrificing that temporary speed over a longer-term increase in that velocity. For one of our key batch computation systems, we were starting to see an increase in job landing times and were routinely getting paged. So we decided to put our planned project execution on hold for a 4-week reliability surge. We diagnosed root causes, and we then fixed some key bugs in Hadoop upstream. And for the very first time in a year, we've had 2 straight weeks with no incidents or pages. Next, for new systems, we want to be able to design tightly coupled, tightly aligned, loosely coupled services or systems. Sometimes we are just blocked by other teams to ship our own software. In such cases, it is important to then establish that loose coupling in your software abstractions and seek that early alignment with the teams through service level commitments. Last, systemic tools and support. Sometimes you could just lack those tools like a continuous build and delivery system. This is where it becomes important to escalate it to your leadership or organization to say, hey, here's what the team needs to be set up for success. For all of these areas related to unblock, change rate is the metric that you can use to track, to measure and analyze your frequency of deployments to production. So if focus ensures that you're solving the right problem and speed confirms you are, quality is what keeps you honest. This is about validating. Does it work as you need it to? Failure rate, which is how often are breaking changes introduced, and mean time to recover, help assess that overall quality of your work. Now, having started off as an automation engineer myself, I've come to deeply value the importance and the predictability that can come with a focus on quality. One of the enterprise products I led had a typical release to customers of about 1 to 2 years because it had a waterfall delivery model. We identified those common failure points of this product and the associated interfaces, which were most suited to the integration scale issues. And then we front-loaded most of the scale and performance testing toward the beginning of the development process. As a result, we were able to ship key features within 5 months because of the shift, and for the very first time again since the product's inception. Quite recently, for one of our async event processing systems, our deploy success rate fell to 20%. This was a system that was used by over 1,000 engineers multiple times a day. So it was very heavily impacting our developer productivity. We had a choice to make. We could take a 6-month rewrite to isolate parts of the system and make them super awesome, and then increase the deploy rates. However, the team decided to audit all the failures, and we focused on the most common failure pattern. And through that data-driven decision-making, we were successful in increasing the deploy success rates from 20% up to 99% as of yesterday. So there are times when improving quality through data analysis can provide that short-term relief while improving long-term collective developer velocity. So you've planned, you've executed, it's done and shipped. This is the time to maximize your impact. Are folks truly using your stuff? Are you actually seeing movement toward your North Star? This is when we hone the what and validate the why. Remember, you started off by deciding whether it was worth solving the problem that you now have developed your software for. So this is the time to start cashing in. Go back to your metrics that you'd identified in the planning phase, and then evaluate how shipping the code has impacted those. You will also find that this exercise can be extremely gratifying and energizing as you see the metrics move as a result of your work. Quite recently, we shipped some work expecting to see change, and then we moved on to solving other problems. Looking back retrospectively, we realized that we had needed to build some adjacencies to the shipped work to actually capitalize on all that effort. So sometimes you need to evaluate what that additional 5 to 10% looks like to realize the most impact. It could be a marketing strategy, maybe a UX improvement, a small optimization like making your load times much faster, or in many cases, just better documentation. So take that time, bring it home, because this is when you will realize the most impact. Lastly, I'd be remiss if as an engineering leader, I didn't call out ineffective management. We need to hold our senior engineers and managers accountable for building and driving engineering velocity. And if they're not working out, then as hard as it may be, it might be time to let them go. I worked on an enterprise release years ago, which had consistently slipped several quarters and then years of delivery. This was because one of the managers was fairly new to engineering management and didn't demonstrate a growth mindset. Due to leadership inaction in addressing this, the company canceled the whole project after years of engineering investment. So as organizational leaders, it is our responsibility to provide the right, timely, and actionable feedback to help individuals course correct and avoid those downstream pitfalls. Quite recently, one of my teams shipped a cloud cost dashboard to give teams observability into their cloud costs. We aligned with our leadership, we prioritized product teams over our other big use of finance, and then we iterated with a few users before we made it broadly available. We also made lots of noise about it at our all hands and engineering org meetings, and we made it a mandate for teams to talk about their costs during their quarterly and business review metrics. A couple of quarters down, we started seeing an organizational awareness into their respective cloud spend, which we didn't have about a year ago. And we as a team regularly monitor our metric for cloud efficiency and now have clear insights into how to move that metric. So zooming back out, debugging engineering velocity requires us analyzing the broader system that you operate in, its various components and their interconnectedness. You want to observe the broader patterns, the markers, and create the feedback loops to assess what's truly going on. To summarize, at the planning stage, drive precision through early organizational alignment and prioritization of user cohorts. This also helps build that trust and credibility with your leadership. During execution, drive speed through focus, iteration, unblocking, and de-risking your projects, and then drive quality through early and rigorous testing. Lastly, for delivery, drive that impact through realization of adjacent work streams, even outside engineering, maybe through aggressive marketing or advocacy. As a manager or a lead developer, you now have a playbook to analyze if you have a problem on your hands and then work on your team's engineering velocity. And ultimately, this is super crucial, especially for us as org leaders, to create that environment where people can work together at their highest potential. Thank you, folks.
Thank you so much, Smruti. To everyone, I am reading the right tab in the questions, so roll them in and we will ask the questions. Well, Smruti, this topic about, you've talked about organization structure, engineering management, and I think, I mean, what do you think about having, because in a company you have designers, you have product people, you have developers, and some organizations tend to organize them layers by layers. Some organizations tend to make cross-functional teams. What do you think is the right approach to having these kind of communications between different kind of, people in a company?
Najib, that's an excellent question. And I think I've seen both models work. I've seen a model where you have these squad-like teams where you have these small groups of teams where you have your product engineer, your product manager, your designer, your software engineer, all making up a team. And you have these different squads which are shipping features. And I've also seen a model where you have a centralized product management org which sort of farms people out as you need. And I've seen both models work. I think the key is, what is the scale of your organization? Like, how big is it? Because sometimes when you have a 20-person company, it is not possible for you to have equal ratios where you can sort of equally staff all your teams. Whereas if you're a 2,000-person company and you want to make sure every function has the right career mobility, their progression, you want to make sure that folks are set up for success. So to me, I think the two big drivers of decision makers on how to facilitate a healthy working or org design is about what is the scale of your organization and what are you trying to accomplish? Because it is also that different features or different systems are at different levels of evolution. You could be starting a brand new feature where you might need your product manager more tightly aligned, but you might have a 4.0 version of your software where you more or less are either managing your technical debt or focusing on scale or focusing on reliability shaped problems where you're like, okay, I don't need a product manager, I just need a bunch of engineers to come together and sort of wrap their heads around this problem.
Right.
So to me, it depends on those two things. What is the scale of your company and what is the evolution journey of what you're trying to build for your users, what your technical systems are around. And then you optimize for that. And depending on that state, one or the other works better.
Thank you. That's amazing. Robert is asking, is a high change rate always good? If I annoy a user with too many updates, or if I do products like airplanes?
And that's a really good question, right? I think to me, like I went back to this bit, which is metrics at best are an imperfect tool for that tactical or strategic prioritization. I think it in itself is necessary at times, but not sufficient to get the full view of the system. In Robert's example, if you're shipping airplane software, you want to be very, very, very sure that it is highly reliable. You've tested it for everything. And then indexing around change rate might not be the right thing to focus around, right? You want to take a look at your entire gamut of metrics and their quality, and the quality control around it would be the one topmost metric that you then index around. So I think my short answer here would be, it would be incorrect for us to take one metric in isolation and say, I'm going to make this one better and always focus on that. It is very dependent on the context of your software. If you're shipping mission critical lives matter, the top tier software, then you better be sure that you've got a lot of rigor and quality baked in. So I'd say context matters, and obviously software you're shipping matters. The key is for org leaders or managers or senior leaders, senior engineers, to take a look at that, that the big brother dashboard of sorts, to say, what are all the things that are sort of blipping? And does any look sort of funny that is worth poking in? But optimizing for any one all the time is definitely a recipe for disaster.
Right, right. Thank you. Jolt is asking, can we get the slides? I want to read it again a couple of times. Jolt, yes. Well, it depends if, Smruti, you agree to us sharing the talk later, then yes, you can rewatch and get the slides. Anonymous question, I don't get the part with letting someone go. Was it about the engineering manager that has to be let go or the team?
So for that particular example, it was the manager themselves. I've been leading teams for about 12 years. So I'm my harshest critic. And my one standing thing with my manager is if I'm messing up, give me that feedback early because the blast radius becomes very high. And I at no point want my team to suffer because I'm not showing up well. And so for me, when I was giving that example, it was more to say, you've tried everything in your playbook and you've sort of diagnosed each of the systems and everything looks good. But there is this non-zero probability where either we haven't created that feedback loops for the people on the team, where sometimes they're not capable. And there, what are things that we also want to focus on? Because sometimes that can also get in the way of engineering velocity. So that example was specific to an EM, not the team.
Right. Well, thank you. I think just in general, this topic interests me. I don't have an exact question, and we have no more questions in the chat. Smruti, thank you so much. And